define the term mapping. Mapping is the same as function. Let A and B be a non-empty sets. Then a mapping, also called a function, f with definition space A and value space B is a rule which assigns an element from B to each element from A. From this, we write function A to B and say f is a mapping from A to B. From A to B. A is domain, is the origin of the element, is the starting point. Domain is the lambda set. Pre-image and image. For each domain, there is only one codomain. Y is codomain, X is domain. So to be a function, there are only one element of the codomain to the domain. The space A and B, space B, the assign an element from B to each element from A. Okay. Domain only can have one codomain, but the codomain has more than one domain. Let's see. For each domain, there is only one codomain. The x of the function is called argument or input value. Does the following depicts a function just fine? No. The x is the domain. Yes, that's the domain. The domain has more than one codomain. This is wrong. No, they are not, because some of the x value has more than one y correspondent or codomain. To be a function, each domain x must be uniquely assigned only one y value, one codomain. What is meant by domain and range of a function? The domain of a function is the set of values that we are allowed to play into our function. The domain is the x value of the function f of x. The range of the function is the set of values that the function f of x can assume. This set is the value of the function shoots out after we plug an x value in. Range are the y value. Composition functions. Composition of functions. X, F, the notation can be written as G function 1 or G after F. G composed with F. If Fx is equal x plus 3 and G is equal x to the roof, then G after F is x If f of x belongs to C, applies to all x belongs to A, then the composition of the function hang G in defined by G after F, AD, G after F, X. Oh, you don't get it. I just jump it. Graph of a function. F of x is equal f plus 3. So this is the graphic. For each 1 plus 3, 4, 5, 6. Graph of the power of 2. X to the roof. This is the function. F of x equal to x. This is the graph. F equal to the constant. F of x roof, x to the roof. This is the function. Draw the following graphs, real to real, with f of x, x times 1, plus 1. It's real, so include the minus. Minus 1, minus 1, 0. Create a table for f of x. 2 divides 1 times x to the roof. For the value range minus 3, x, 3. Make a table. Minus 3, 2, 1, and f of x. Minus 3 to the roof times 1 for 2, minus 2 to the 2 times you consider there is a minus divided by 1. Minus 2, 4, 4, 1, 1, 1 for 2, 2. 1, 1, 1, 2, 0. 1 to the 0, mantém 1. This is 1 to the roof the same, times 2 to the roof 4. The same. Draw the graphic of the following function. R to R with x for x upper or equal 0, minus 2 for x. This can be represented by two different lines. It's the same, x, the same, and maintain the minus 2 to the second part. What is meant by function injective, subjective, and bijective? Injective. A function is called injective if each element of the value range b, the codomain b, has at most one preimage. The value can have no preimage, but can't have more than one. Injective. You only inject in one. You can inject no one, but you must have inject just one. Think about a nibble of a medication. You use in one person or in no one, but you can't never use in more than one person the same nibble. So A, B, C, A to 1, B to 2, C to 3, the 4 is alone. So this is injective, but there is no repetition on preimage, and okay. But the 3 here have two preimage, so this is not injective. Example. Of functions. The function x to the roof if x is more or equal to 0, and f of x minus 2 to the roof if x is minor than 0. It's an injective function for each y. This is only one x. Not injective. Because there are two. This is a function. This x don't repeat, but it's not injective because to the y the x repeats. Surjective. A function is surjective if all of y living on codomain exist at least one preimage. Surjective. Surjective, everyone needs to have at least one preimage. Surject in Portuguese, you can think about sujeira. Using the example of the nibble, the two sujeira because use as a dirt nibble because use the same nibble to two preimages. So this is surjective. To this graph and function become surjective, the codomain must have, so in this case there are, this is interesting. Look, in this case we are use real to real, and f of x is x to the roof. But we don't say here the real is positive. So this value of codomain also exists, but we don't have an x to it. So this x, this codomain, don't have a preimage. So this is not surjective. But with the same example, if we say this x, this real number is plus, so r plus, this value don't exist. It's only upper to the x. So all values of y will have an x. So it's surjective because they have at least one x. Look, they repeat. So they are not injective, but they are surjective. Now, bijective. Bijective. The function bijective if for each element of the range codomain exists exactly one preimage. You can't repeat, no one can be alone, and the relation is 1 to 1. This is bijective. They need to be surjective and injective at the same time. So exercise. Is the function f of x f to the 4 for all x belongs to R and f of x belongs to R injective? Explain. The function is not injective because for the same y there are two possible preimage x. Look this example. If x is 1, x is 2. Minus 1, minus 2. So is the function f of x cardinality of x? No. This is not cardinality. This is modulo. This is make the value of x always positive with x belongs to R, and f of f belongs to R surjective. No, it's not, because in this function you consider the contradomain contain negative numbers. Only the you don't say it because this is not with a positive sign. You only make the x positive but this is not really positive. You use a negative fx. I don't know. I need to draw it. Okay. Check whether the function r to r, which f of x 3x plus 5 is bijective. So 3 times x plus 5 minus 1 minus 0. If you use this value, you obtain this value and obtain this graph. So no repetition of x, so is injective. The y don't repeat. All y has an preimage, so is surjective. Then is bijective. There is other explanation in exercise and book using only the formula. Invertible function. Invertible function. You can find the inverse function by substitution x by y and y by x, and then isoling y. Example, f to the minus 1. I think minus 1 is only to represent inverse function of x. Okay, of f of x is equal to 2x plus 1. This is the same of y, x, change x by y and y by x. So x equal to y plus 1, x minus 1 is equal to y. Y is equal x minus 1 divided by 2. This is the inverse function of f of x 2x plus 1. Interesting. What this is used for? This explanation is from YouTube because I don't understand the book and the video. A function is invertible exactly when is bijective. So when it's not bijective, I can't invert. What do you think about it? Okay, let's stop by here.